Chapter 4, Lesson 3 of Pre-Calculus. Now that we've talked about coterminal angles, eventually we're going to get to a point where you'll see that the 6 trigonometric functions then can be applied to any angle that we want. And we'll have to make that connection, but we want to talk about connecting the trigonometry now to those coterminal angles, and we're going to have to do that in a couple of steps. So in this video, we'll talk about one of those steps. And we want to talk about it in terms of a point that's in the coordinate plane. So we know that this is our x-axis and this is our y-axis, and if we take a point anywhere, let's say right here, and we label that point xy, how does that relate to, number one, coterminal angles that we've been talking about, and number two, the trigonometric functions? Well, if I have a point, if I were to go ahead and take a line from the center here, let me see here, and draw it through that point, and then I were to extend a line perpendicular down to the x-axis, then this point, you'll see, the length from here to here is going to be my x, and my length from here to here will be my y. And then we could calculate the length from the origin to this point by doing this Pythagorean theorem. X squared plus y squared is equal to that length squared, which if we simplify it, then this length here, let's call it r, will be equal to the square root of x squared minus y squared. Now what I've created here is a right triangle where theta is one of those angles we've been talking about that you rotate from the initial side here. And because we have a right triangle, we can now apply our 6 trigonometric functions. So the sine of this angle will be the opposite side, y, over that distance here, which is r. The cosine of that angle is going to be the adjacent side over r, and the tangent of this angle is going to be the opposite side, y, over x. So you can see that all 3 of our trigonometric functions, as well as their reciprocal functions, so all 6 actually, are related to this coordinate. Whatever the coordinate of this point is, the y value over this r value, or distance from 0, will give me my sine. The x value over the radius will give me my cosine, and the y over x will give me my tangent. So one of the connections I want you to make here is the fact that you'll see that the sine ratio and then also the cosecant, because they're reciprocal functions, are related to the y coordinate here of this point that's on this line. The cosine and therefore the secant, which is its reciprocal, is related to the x. And then the tangent and then the cotangent by its reciprocal then would be related to the x and the y. Okay, cotangent here would be y over x. Okay, so this would be r over y and this would be r over x. So hopefully you see a little bit of the connection here that I can pick any point along this line here. In other words, if I took this point right here and I took the x and the y, that was my point, you'll notice that the sine would still be, if I drew this line straight down, and this would be x and this would be y, that the sine and the cosine of this point would be exactly the same as the sine and cosine of this point, and the tangent. And if I chose this point here, the sine and the cosine of that would be exactly the same as the sine of any and cosine of any point along this line that goes through this. So you can see if I then calculate a coterminal angle, where I add 360 degrees to it, then the sine and cosine of that coterminal angle is going to be the exact same as this original one. So you can see when we put these coterminal angles together with the sine and cosine, you can see that these sines and cosines and tangents, these trigonometric functions, are periodic because they're going to repeat every 360 degrees. Are you going to do something? Anne? Are you?
Putting this stuff in the dryer.
Okay. Thought you were going to come poke your head in my video. So let's extend this just a little bit further in our discussion and tie this together a little bit tighter. If we were to think about the quadrants, this being quadrant 1, and this being quadrant 2, and this being quadrant 3, and then this being quadrant 4. And we make the connection that the sine function is related to the y value. What can you tell me about the sign, positive or negative, of the sine ratio in quadrant 1s and 2s? Quadrant 1 and 2. Because the y values in these quadrants are positive, then the sine function will also be positive. And in quadrant 3 and 4, because the sine value is related, or the sine function is related to the y values, in 3 and 4 the y values are negative, so the sine function will be negative. And we can relate the same thing to the cosine. If the cosine is related to the x value is positive in quadrants 1 and 4, so the cosine function will be positive in 1 and 4. The x values are negative in 2 and 3, so the cosine function will be negative in 2 and 3. And then if we think about the tangent ratio being a ratio of y and x, if both the y and x are positive, the ratio would be positive. And if both of these are negative, meaning a negative x over a negative y, well, two negatives make a positive, then the tangent function is going to be positive in quadrants 1 and 3. And the tangent function is going to be negative in both quadrants 2 and quadrant 4, because in quadrants 2 and 4, one of the two values, x or y, is negative. Okay? So to wrap this video up then, tying together these coterminal angles, that if we know, if we have an angle, we can choose any point that we want on this terminal side and draw a line creating a triangle, which we'll talk about. That's called a reference triangle. And we can actually then use that to calculate the coordinate of this point. So the point's coordinates, whatever these are actually related to the sine function and the cosine function, because the x value over this distance will be the cosine, and the y over the distance value will be the sine. So let's take a look at an application of that, or how we're going to use that. So for example, let's take the point 5, 3 here in quadrant 1. So the point 5, 3, if I take and draw a line through that, and then I draw a line perpendicular to the x-axis from that point, and create what we have the reference triangle, then this is theta. Now remember, the sine and cosine along this is going to be the same for every point along here. So the x value would become the adjacent side, because that's the x, that's this far, and then this is my y value. So in order to do my trigonometric ratios, all I have to do is calculate the length of this, the r, and I can write my ratios. So the square root of 5 squared plus 3 squared is going to be my r. So 25 and 9 is 34. So the length of this, or r, is the square root of 34. Now that I have the three sides of the triangle, I can write my ratios. So the sine of this angle is going to be the y value, 3, over the square root of 34, or opposite over hypotenuse. And then the cosecant, the reciprocal function of that, would simply be the square root of 34 over 3. The cosine of the angle, which is the x value, would be the x value 5 over the square root of 34, or adjacent over hypotenuse. The reciprocal function of that would simply be the reciprocal of that. And then the tangent function is simply the y value over the x value, or opposite over adjacent. And then the reciprocal function is simply the reciprocal of that is 5, 3. So if I'm given the coordinate of a point, I can determine all 6 trigonometric ratios by putting the point, just plotting it in the quadrant that it goes in, drawing my reference triangle, and then determining the missing value, and then just writing my ratios given that. The main thing is here to remember that the y value is related to the sine, the x value is related to the cosine. This is going to be very important when we look at quadrantal angles. So let me do one more example so you can kind of see how this ties together. For this example, let's just change the x-coordinate to a negative 5, 3. So if I plot that point, I'm now in quadrant 2, negative 5, 3. But I still, if I draw my radius and then I draw a line down here, I create my reference triangle, so this is theta. And again, this is my y and this is my x. All I have to do is calculate this. Now this is going to be the same thing we had before, because we square a negative, it becomes positive. So now if I write the sine ratio, it's the y value, which is a positive 3 over that r, which is 34. And again, because it's a y value, and y values are positive here, a positive sign makes sense. The cosecant then is again simply the reciprocal of this. Now if we look at the cosine, which is related to the x value, you'll notice that the x value is negative, so my cosine function is going to be negative. And again, then the reciprocal of that, it's still negative because it's the reciprocal of the cosine, and the 5 is still negative, so we still have our negative value. And then the tangent is one of the values, it's a relationship between the y and the x. One in the y is positive, the x is negative, so 3 over negative 5 gives me my tangent ratio. And then the reciprocal ratio is simply the reciprocal of that. It's still negative because it's this ratio of these x and y values, so all of that remains the same. Okay, so given the coordinate of a single point in a coordinate plane, we can determine all of the ratios from that, because if we draw a line through that, creating a terminal side angle, and again, no matter where I go on this line, the sine, the cosine, the tangent, the cotangent, the cosecant, the secant are all going to be the exact same value because this angle never changes. And these are all similar triangles, and so the ratios of their sides is going to remain constant. Okay, we'll pick this up in the next lesson, where we then look at the sine, cosines, and tangents when we put these on what we call the unit circle.